All right, so let's dive in. Also, a very warm welcome from my side to our last session today. Food waste, champagne, and artificial intelligence in aviation is the title of my presentation. And I have the pleasure to take you onto a journey through the Lufthansa Group and a couple of AI projects that I have the pleasure to work on during the last 5 years when I've been working there. And they are two quite tasty projects because they are built with our former caterer, with the LSG group, so they are all related to food, which should put us in a good mood for the evening. And so without further ado, I'm Alexander Motzek from Zero G. If you look into the Lufthansa Group, they often say we are the powerhouse of AI in there. We do all kinds of things using data, artificial intelligence. We also did what we have seen in Singapore with these analysis of these turnarounds. We also have built that and experimenting with that at a major German airport. So it's pretty fun working there. And you get to work on really, really interesting projects like the two I'm going to present you now, which are coming directly out of our cabin. So, for example, out of the cabin of this beautiful 747-8 that we are seeing there. And it basically starts back in 2018 with a project that I've been working on, which kind of reflects always my experience in our premium products. Because when you're flying with our premium product, you know we have quite a nice wine selection, and I really adore them. Especially on the North American flights, we always have one Chardonnay, slightly oaked, like we had a Montes Alpha 2017 vintage there. Absolutely adorable. I love it. And we received these kinds of feedbacks a couple of times. We also receive complaints, but we love getting this positive feedback. And so there might be actually some compliments from our guests that we really have a nice wine on board. And our pursers actually do have iPads with them. So if you're flying Lufthansa Group and you ask a purser or tell something to the purser, it is heard, it is typed in into the so-called Cosmic application, and then it's transferred into a central place where all these comments are read and being processed to improve on that or to make it even better. And these comments eventually then also arrive at our caterer. Whoever that might be. It used to be LSG, now it's Gate Gourmet, and these caterers then not only receive the comments from like Lufthansa, they receive it from everywhere in the world. And back then, this was like half of the world. They got the comments from Lufthansa, from China Airlines, from Alaska Airlines, from like everywhere, equal up to like around 50,000 comments each every week. They received at the caterer, and they were just like, okay, we're not going to read that. But they still, well, they need to show the best effort. And then this is where basically we stepped in and said, well, this is a classical problem for an AI, and let's just build it. Let's build a classical natural language processing system that reads the comment and classifies it into multiple dimensions, such that they don't need to read 50,000 comments. They get simple statistics out of them. Because with each and every comment that we receive, we get a route, we get a date, we know what catering was on there, and so we get really nice statistics. For example, that we have good clusters of compliments for the wine, for the appetizer, whatnot, on the routes towards North America. And so this immediately generates quite great insights thanks to the ability of an AI being able to read a text and put it into different categories. And for example, here you see it detects it's a compliment, affected product is wine. That's all we really need to know. But it might also happen that especially, and this was a real finding in this project, especially coming from Rio, that the champagne wasn't cooled properly. And this might actually happen, and this was one of the most frequent comments out of Rio, because they were quite lazy with the dry ice, and so the trolley got warm on the way toward the aircraft, and as the champagne is served quite early on, it didn't have time to cool down again, and so the champagne was served lukewarm, which was quite upsetting to them, to the passengers, but the cabin staff was actually quite upset about that, being reflected in lots and lots of these comments being evident from the data set. And in this case as well, the AI correctly detects it. It detects it's a temperature deficiency, it is too warm, affected product is champagne, it's a complaint, and I really like this example because it shows it does not do a simple keyword search, it really tries to understand the text. So it detects that the negation of being cooled somehow implies too warm, so it has somehow learned that from the data. And it worked pretty well. So in like manual evaluations, we took a couple of hundred comments and basically said to an expert lying there, sitting there, hey, have a look at these classifications from the AI. Does it work? And he said, yes, that's like above 90% is correct. And so that saved them a lot of work. They didn't need to copy them in different formats out of Excel spreadsheets anymore and paste them somewhere. It just went through one automated pipeline and they got everything they needed. And I brought along with me a couple of real-world comments there, and the variety and the information that you can derive from that are pretty amazing. Because you're not only getting these comments like all beverages hadn't been cooled, that's quite common. In the middle we have a comment from Air France where we got some praise for the amuse-bouche, which was really, really nice. Also correctly classified as compliment and in the starter category. And down here, this was also something very interesting because originally this project only originated from the complaint department. So they were only interested in processing the complaints. But coming from that comment here, that the presentation of chicken did not look very good and the sauce spilled out basically during takeoff, that got the product development onto the screen because they said, well, give us that information if it's like belonging to the food production, that we can improve the process behind that. And that was basically an information that got lost before inside the cabin. They were always experiencing it, they were cleaning up the mess, and then when the plane landed, everything was, well, fixed. And the caterer didn't know about that. But with the comments, they could improve on the product, and yeah. So it was, from an AI perspective, a really great project back then in 2018, and the business was also extremely happy with that. Yeah, so it was really, really fun exercise. And from a machine learning perspective, we built a quite nice Bayesian optimization framework around that optimized onto the pre-processing of the individual texts and onto the model selection. Because if you have a quick look back here, these are 8 different dimensions in which we are classifying. For example, affected product had then 200 different values from which you can select. And basically every individual dimension had a different AI. It turned out that it perfectly tailored pre-processing with a different model worked best for the individual dimensions. And this was 2018, worked perfectly, still works perfectly. But as we have learned this morning from the Hugging Face guys, there has been some research lately in natural language processing, especially in the world of transformer models. And this is what we basically just have analyzed and put a thought into it. We took the data from back then and applied like zero-shot classification. Instead of taking 40,000 labeled data points and training it from scratch with heavy pre-processing, translating everything to English and evaluating it, we said, well, what does happen if we take such a very big BERT model, do no pre-processing at all, no translation at all, use 0 data points and feed it to the very, very raw data? And I apologize, so the labeling task was in German, basically, and we took a couple of examples, and like this Spanish example of lukewarm champagne was then processed by this zero-shot, it was a BERT, it was a classical BERT trained on 120 languages for zero-shot classification. It correctly classifies it. It detects it's a temperature problem, it's something with the content, it's a special occurrence, it's champagne, it's the service, no, but not on the ground, that is incorrect. It's the non-food area, it's related to the drinks, and it's a complaint. And this is pretty amazing because it like classifies from Spanish without any pre-processing into German. And yeah, so I'm pretty excited what will happen in the next 4 years in that area. But not everything was working so great. This is working pretty good. Once it goes into like you need heavy process know-how, this zero-shot approach fails. But if you just throw in like 2, 3, 4 samples, it works pretty easily. So if you recall from the previous project, there was this area in which process state was the most likely cause for this individual complaint. And this is something you need to have very huge knowledge about the process, how all of that works, in order to do the classification correctly. And this is where basically zero-shot classification failed, but which can be trained on. Or you just use the simple approach from 2018. So, great project. gives great information, great business value, was pretty easy to implement. I think the initial project was just 2 weeks. However, it just gives you snapshots of individual impressions. The things that are entered there must be so important that the purser hears it and opens up the iPad and types it in. It's a quite delivers high quality of data, but not that much of data. And so we said back in 2018, well, do we have another source for getting the feedback from the passengers inside the plane? And so we said, well, the purpose of the caterer is to serve food, so let's have a look at the food. We place all of the food nicely on trays, serve them, and basically we have the economy, we have the premium economy. They look kind of similar, but they are always plated a little bit differently, depending on the routes, depending on which class you are traveling in, also which current catering option is served there. In the business class, obviously, everything is much fancier, coming up even to like the first class experience for the Japan flight, which looks completely different, but this is like the variety which is served on these flights. And we said, do we get any lever on that to analyze it, how the passengers are actually perceiving the food on a daily basis? And we said, yes, it's pretty easy, because everything that is put onto the plane on these trays eventually comes back down and will be stored in the trays again, because the great thing about the Lufthansa Group, they are not plated, they basically are put into the plane just as they are served. So we can get them back just as they have been served. And so we sent a working student down there to take a couple of pictures for some United flights, I think it was, like flew 2 to 3 times back and forth, and always took pictures of the catering, how it went out of the airplane again. And just by putting the pictures together, you could see a really, really nice, got a really nice picture of that, because you saw, well, people are quite eager to eat everything, but you start to notice these small green things here. This is like the salad dressing. No one touches basically the salad dressing at all. And so this was one first insight that you got just by looking at it. By looking at it, you also noticed that there were a couple of unserved yogurts on that plane. And down at the business class plates, you notice that there is quite a lot of residue of this brown sauce, which was like a satay sauce served with noodles. Apparently, either it was too watery or didn't taste that good, it wasn't eaten that much. And so that information you got directly just by looking at the images. And we said, well, this is another classical computer vision application. Let's build it. And basically, what I did to create that AI is I downloaded our pixel images, which is our stock images, because they just look nicer for presentation, and I labeled our stock images, trained a segmentation AI on that. I think it was a unit squared on a couple of 100 images, and it worked pretty well. Even in economy, it's the same AI being able to detect images, detect food on images from the economy, from the premium economy, in the business class. It even got the food in the back, in the bouquet, in the unshop area. It even was able to detect the food on our first class Japan menu. Yellow was, if I recall correctly, was the dessert. This is not the dessert, this is some side dish, but I think that's okay. It even recognized that there's package on the left side where the rice is stored in. It even detected that this is somehow kind of a food. And it worked pretty well. It even worked inside for the images that we have from our lounges. And this was, yeah, pretty impressive. And even at scale, so if it the image, the food portion of the individual pictures becomes quite small, it detected it pretty well. So I thought, well, this looks like I have an AI that is pretty easy or pretty good at detecting food and images. So I basically took the images taken by our working student again and basically threw it in. And with that simple AI, we directly got a great overview where food is left over. And this is now basically the connection from how you transform this business problem into the AI problem, and now coming from the AI result, which is just like segmented and filled with pixels, into some business insights. Because you can now take these labeled pixels and basically just count them over individual flights. And the more pixels you count, the more food pixels you will get off the airplane, and which tells you how well they have eaten the food, and if it's gonna rain tomorrow, maybe. And so these are some example insights from these 4 United flights. So you're noticing in the middle, 2 flights actually had quite the peak towards the right. So there were lots of food leftovers on these flights. Towards the left, you had 2 flights which were pretty well eaten. So you had less pixels with food leftovers. And when we asked our colleagues from the LSG what likely happened there, those were the cheese desserts, which weren't eaten, because on that flight they also served soft ice cream, which is served like in parallel to the cheese, and then everyone takes the fresh ice cream instead of taking the cheese, so all the cheese was left over when emptying the plane. And yeah, so you're also seeing that down here. So it detected 33% main leftovers, 53% dessert leftovers. And so this is like the information you can get out of these analyses. And this worked so well that it drove our former caterer, the LSG group, to develop this into a full-size product. This can now be basically ordered as a service at LSG group. And they have made a small promotional video, which is quite fun to watch. And yeah, so it's now a live product inside the Lufthansa group.
Improve their customer satisfaction, efficiency, and sustainability. That is why the right meal planning and optimized loading are crucial. The problem is, we don't get direct feedback from passengers. We don't know what dishes they liked, what dishes could be improved, or when they wish to eat. Manual checks of the returning trays are both costly and time-consuming, which is why there haven't been any fact-based answers to these questions, at least until now. This is all about to change thanks to artificial intelligence.
So, and this fills me quite with proud because of these small ideas that we had just in a brainstorming session and these small AIs we trained just after work and to show it that it works. And out of these basically ideas and connecting the business with the AI sides, it's now a full-blown product inside the Lufthansa Group where we have that in production. And yeah, so this was just a small insight on natural language processing and computer vision, what we are using. We are using lots and lots of more stuff within the Lufthansa Group, especially in the revenue management part, in forecasting part. We're also using reinforcement learning for making our flight plans more stable, which is quite impressive. And especially also in the predictive analytics. I'm going to have a chat with that later on. Predictive maintenance area, also quite keen on utilizing AI in there. And yeah, so very interesting and awesome times for artificial intelligence within aviation. And if you do have any further questions, just chat with me over a coffee or over a beer somewhere. If you're interested in joining us, we are hiring. If you're interested in the consumption analytics, give Robin Zippel a call. He's from LSG. Or just write me an email. And with that, I would say thank you very much for joining my last session. I hope you all got hungry.
Thank you very much. Questions? Daniel? Yeah.
Thank you. I like this talk. It is very original. My question is, for sure, you thought already about other application domain, like a restaurant or things like that. I don't know.
We especially had some communications or some chats with the cruise line industry, because they have, the problem is even bigger, because they have so many passengers on these large cruise ships, and everything is loaded well, when departing the port. And basically, if you reduce food waste there, it's an extremely large lever. And they were extremely interested also in just knowing like how large should we make the portions. Because if you have an all-you-can-eat buffet, you don't want them to take a very large plate and then only eat half of it. Better it would be to like have to eat 3 plates with smaller portions.
I have a question.
Just one question about the computer vision part.
Mm-hmm.
So might be quite a technical question, but we very often have difficulty when we have diversity. So here on the plane, how many different dishes did you have to train the model on? Was it like 100, 1,000, or different kind of food?
So the computer vision actually was quite easy to train, because basically I took 100 different images from our database and trained it on that, and just to classify if is it the main dish, the dessert, is it the side dish, or I think the salad. And that was pretty easy and quite versatile. So I think I didn't even label the Japanese one. It just was able to classify the Japanese one directly. I think this is due to I used a pre-trained UNet, trained on ImageNet, and ImageNet is full of food images as well. So I believe it is already has a quite good sense of how food looks like.
Questions?
Does it also have like how much the food is left? Or like what quantity is it left?
So in my initial proof of concept, it just counted pixels. So it was only able to tell to like compare flights with different flights. So we get a relative figure out of that. But I know that the LSG is currently working on like transferring it from like pixel or image base to like kilograms. Because there is some mapping available. You don't have 3D vision, but you can estimate it. If you see like a bread loaf, the AI can have some knowledge about how heavy bread is. And if like half of the bread roll is empty, you know it's like 20 grams. And so they are working on it because they have all the food available and can measure it.
I can ask a question. When it is actually implemented, how do they take pictures of the leftovers?
That's a really good point. So the LSG had multiple takes at that. One thing was like a bridge that can be installed over the like the tray belt, where they put out the trolleys arrive, they take out the trays, they are put on a belt, and then they are running through there, and iteratively they couple of people take off all the leftovers, clean everything, and then afterwards everything is clean again. So at the very early stage where the tray is put on, there was a bridge constructed over it with a camera taking picture of that constantly. But that only works in certain kitchens, because at some other kitchens there are no belts. They simply take it out of the trolley and like move it away. So for that they built like a mobile tray analytics station, which is like just it's like a baggage. You can just flip it open, looks like James Bond, and then you can put like trays on it, takes pictures, and directly upload them into the Azure cloud where it's live analyzed. So the idea is you buy this service for a couple of flights to get an estimate, just by sampling 2, 5, 10% of all your flights, and get an estimate over how well everything is eaten.
Thank you.
Alexander, just out of curiosity, do you see massive variations between the different destinations with the same set of food? I know that this is, again, challenging because for the different destinations, you've got different menus, right? But what is your take on that?
I don't know about the food or about the consumption analytics, because these results, basically, they are with the LSG group. But for the comment analysis, you see extremely different results, especially on the complaint side, which complaints occur. We constructed some, initially we weren't sure if we need to translate everything from the original language, like there was comments in Russian, in Chinese, in Japanese, in Portuguese, in English, in German, and we initially said just throw it in without translating it, but just coming from the language itself, it was quite easy to map it into some kind of complaint category. So just by the language in which it was written, you got a pretty good idea what this comment will be about. And so there is a strong bias in like areas or countries of complaint categories. And that's why we translated everything to English, to have it more general, to not classify the language, to classify the content of the comment.
Thank you. Yeah, it's still related to the quantity. So I just have example. So suppose there is one kind of a whiskey, everyone likes it. So everyone takes one type of whiskey,
But the problem is it's served too much, so nobody drinks it completely. Just a little bit is left. But what you will see in the images is like, okay, everyone left that particular whiskey.
That is exactly the point where then the business must kick in, where you get like the result from the AI tells you there are constantly leftovers, but the conclusion which you can draw from that must be made by the business. Is it due to like something being served in parallel, which is more tempting? Is it just you can't slurp out the very rest of the whiskey out of the glass, maybe? Is it because it's too much, or is it too strong? Does everyone just take a small sample? And so, like, the conclusion coming out of we have food waste, and the reaction to that is something that the business must take. And so I currently don't see how the AI will be able to tell the root cause for the individual food waste. But thankfully, we have the caterer for answering these questions.
Oh, yeah, thank you very much.
Thank you.